I studied physics and oh, was it hard. But I reckon that physics is by far the simplest science. Why? Well, whenever I told people that I was doing a PhD in theoretical physics, they looked at me like I was some kind of wizard. But I was just following rules. Sure, mathematical rules that may look super scary from the outside, but still, clear rules. I think the real wizardry happens when you try to do science, let's say, on human behavior. Humans are so complex. They don't seem to follow any rules at all, not even scary looking ones. We just typically meet humans more often than formulas, so they seem familiar and not scary. Sure, physics can be less intuitive than, for example, biology, when it deals with concepts far from everyday experiences. That's because physics wants to cover everything, the whole universe, but extremely reduced, at an extremely deep level. In contrast to other sciences, explanations in physics are at a very fundamental level, close to the basic laws of nature. Combine that with often poorly presented mathematical formulas, and yes, learning physics gets really tough. But doing physics? Well, doing science doesn't get any easier. To explain this, I'd like to start by pointing out that science is nothing but a method. So we're on the same page about when we call science simple. And then I'll mention 4 reasons why physics is the simplest science, with the 4th being the main one. What is science? Well, chemistry, archaeology, medicine, and so on. And of course, whatever they tell us. Well, yes, but no, not really. Those are branches of science and the theories they brought us. But in its essence, science is not about what you study and with what explanations you come about. In its essence, science is a method, a technique, or a set of techniques. A technique with a special goal. Deriving those explanations. Approaching the truth, or at least a description of reality that is close enough to the truth to be useful. Science is about discovering the world we live in order to understand how it actually works. Just like this channel is about discovering science and especially physics in order to understand how it actually works. So if you're curious, please subscribe. Thank you. So, science is a method that's supposed to help us move towards a correct understanding about the world. How does this method work? I talked about its foundation in detail in this video. Importantly, you set up experiments to collect real-world data that lets you improve or disprove an idea, hypothesis, or theory. When is science simple? Well, first I want to point out that doing science is not simple. Doing science is hard for reasons that could fill a whole other video. Let me know in the comments if you're up for that. So, by simple I mean not so hard in comparison. If you're thinking about going into science, just forget this. Don't worry, it will be alright. No, honestly, it will be fun. So, science is the interplay between experimental data and theoretical ideas, and it helps us to derive descriptions of the world. Thus, science becomes easier the easier it is to get data, develop ideas, and handle descriptions. And of course, we don't just want any data, ideas, or descriptions. We need correct data and useful ideas. Data is correct enough if it actually depicts real-world phenomena. That can be quite challenging, as we'll see. We want descriptions of the world that actually tell us something interesting. We want to be able to make predictions using these descriptions. And we want our theories to cover as much as possible. Newtonian mechanics, for example, allows us to predict a huge range of motions. So, ideas are useful when they lead us in that direction. And this brings us to why physics is the simplest science. Let me start by giving one reason each for why it's simpler to get data, develop ideas, and handle descriptions in physics. And afterwards, I'll give you the main reason for why physics is the simplest science. One reason why collecting data in physics is simpler is no humans. Or at least as few humans as possible. Sometimes humans lie, even though they don't do it on purpose. And even worse, sometimes they don't notice it. So if you have to talk to humans to collect your data, well, good luck. If you don't have to talk to humans but study humans, I also wish you good luck. Not only are humans incredibly complex, it's also quite impossible to study them in an isolated environment. But that's something you want to do if you want to look at one special aspect. You want to isolate that aspect. But if you don't want to lock people in a lab for their whole lives, you get results like these. This figure tells us that participants that consumed alcohol moderately had a slightly longer life expectancy than those who did not drink alcohol. But before you start drinking, bear in mind that people need social contact, and in numerous societies this comes with moderate drinking. So the outcome may have little to do with what was being studied and more to do with social and cultural factors. I mean, building a machine that lets particles collide is not that easy, but at least you can build a machine that gives you quite trustworthy results. Furthermore, we can often drastically simplify experimental setups. Why? Because of the main reason physics is the simplest science, which we'll talk about in 2 minutes. And you want to tell me that math is hard? Speaking of which, this brings us to the next reason. So, physics is expressed in terms of math, and sure, math is hard to learn, but it makes it possible to derive new ideas directly on paper. You can start with what you know, use mathematical rules and derive something new. And the best thing is, you don't even have to leave your house for that. Feynman rules, for example, tell you how particles behave. You can just apply them and calculate a certain particle interaction. Then you can compare the result with an experimental result to see if the theory holds. But if you don't have a particle collider in your basement, you do have to leave your house for that. That's why I'd recommend doing theoretical physics. Furthermore, physics allows us to reuse a lot of concepts in different fields. Conservation of energy, for example, is used in nearly every field in physics, like classical mechanics, thermodynamics, electromagnetism, quantum mechanics or relativity. This applies not just to concepts, but to formulas as well. By the way, a formula is a good metaphor for physics, as it tries to cover as much as possible as concisely as possible. So, I think math and the wide applicability of concepts makes generating ideas easier, even if it doesn't seem so at first. Both result from the fundamental nature of physics. Math offers even more. It's precise and well-defined. Math lets us apply concepts to a lot of different fields within physics. But it also allows us to clearly separate those fields, to clearly separate the different descriptions of reality. That makes handling those descriptions way easier. But when we talk, for example, about humans being sick, we use a macroscopic description. We talk about macroscopic human behavior, but we also mix in microscopic descriptions by using words like virus. In physics, there's no need to be sloppy. We can be precise, which makes working with descriptions easier. Furthermore, we can often also drastically simplify our descriptions, like when we pretend that we're working with frictionless surfaces or spherical bodies. And this brings us to the main reason why physics is the simplest science. In order to understand the world, we can study it in a simplified form. We can move from a complex situation to a simpler one by pretending we could remove unwanted influences, like air resistance or friction. If we're interested in objects falling due to gravity, but not due to air resistance, we drop objects with low air resistance and imagine there's none at all. In physics, we can understand a situation by studying a simplified version of it and treating this simplified version as true. Of course, this makes collecting data so much simpler. It lets us simplify experimental setups and just ignore small disturbances. But this also simplifies the theoretical side. We can often model only one little aspect of something and pretend other aspects did not exist. That does not work in other sciences. There, modeling only a tiny part and pretending the rest doesn't exist would probably produce nonsense. Like moderate alcohol consumption looking healthy. This makes physics so much simpler. It would be so difficult to do physics if you start from reality in all its complexity. It's so much easier to start from clean limits. It's easier to ask, what happens in the simplest possible case? And how awesome is it that we are so lucky that in physics, Answers to this question are usually incredibly helpful. If you want to know where this idea comes from, check out this video. Thanks for watching. Have a wonderful day.